bond line structure, what we do is this: carbon and hydrogen atoms are hidden. And the carbon atoms are shown by zigzag lines. Zigzag lines. Say, for example, you take a compound cyclopentane. Cyclopentane. The structure of a cyclopentane, there is the term cyclo. So there is a ring closure. There is a ring structure. You have studied this in the 10th standard. Pentane, there are 5 carbon atoms. So there is a chain of 5 carbon atoms. Say a chain of 5 carbon atoms, say like this. Okay, 5 carbon atoms. And the pentane, there will be hydrogen atoms on the carbon atoms. Consider the valence of carbon, that's equal to 4. You look at each carbon. From each carbon, 2 covalent bonds are already formed. So there is provision for 2 more covalent bonds. So there will be 2 hydrogen atoms attached to each carbon atom, say like this. And this is the structure of a cyclopentane. Okay. And this is the complete structure. We call this the structural formula of cyclopentane. Cyclopentane, the structural formula. That means the complete structure is shown. All the bonds are shown. But if you hide the carbon atoms and the hydrogen atoms in this, what you get? You will get this shape. A shape of a pentagon. See? A pentagon like this. And that is the bond line structure of a pentane. The bond line structure of a pentane. That is just like a pentagon. Pentagon. In maths, geometry, it is pentagon. But for chemistry, in geometry, it is a pentagon. But in chemistry, it is a cyclopentane. It is a cyclopentane. Similarly, you take a cyclohexane. Cyclohexane. There will be a chain of 6 carbon atoms. A chain of 6 carbon atoms. And the remaining valences are satisfied by hydrogen atoms, like this. Okay. So this is the structural formula of a cyclohexane. Complete structure of a cyclohexane. See, now you hide carbon and hydrogen atoms. Then what you get? You will get the shape of a hexagon. Hexagon. So in maths, geometry, it is hexagon. For in chemistry, it is a cyclohexane. Cyclohexane. If there is a heteroatom, that must be shown. For example, chlorocyclopropane. Example, chlorocyclopropane. Chlorocyclopropane. Cyclo, again, ring is there. Propane, 3 carbon atoms. So a ring of 3 carbon atoms. Then chloro, there is chlorine atom. There is a chlorine atom. So you can show the heteroatom like this. And the remaining will be hydrogen atoms. So in this carbon, 2 hydrogen atoms. Here also 2 hydrogen atoms. And here there will be only Vidur. How many hydrogens will be there? Vidur.
1.
Only 1 hydrogen atom will be there. Okay. So that is a chlorocyclopropane. And if you are asked to draw the bond line structure, bond line means only the bonds between the carbon atoms are shown by the zigzag line. So the bond line structure will be, say, like this. And here there is a heteroatom, chlorine. That is a chlorocyclopropane. Okay. Sometimes you will be asked to expand the bond line structure. You will be asked to expand the bond line structure. The bond line structure. You will be given bond line structures and you will be asked to expand the structure. That means to write the full structure. Say, for example, a compound like this. You are given a compound like this. And you will be asked to expand this. How will you expand this? Say, at each end, there will be carbon and hydrogen because no other atom is shown. And at each corner, there will be carbon and hydrogen. So you take the hexagon part. So carbon, 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 here also carbon, say the hexagon part. You go to the other side. Here there is carbon, carbon at this end, and at this end also carbon. Okay. And to complete the structure, you start from this carbon, there will be 3 more hydrogen atoms. Similarly, here also 3 more hydrogen atoms. Okay. And this carbon, you take this one. On this carbon, there will be only 1 hydrogen atom. You come to this, there will be only 1 hydrogen atom. And these two, there will be 2 hydrogen atoms. Here also 2 hydrogen atoms. Here 2 hydrogen atoms. Here also 2 hydrogen atoms. And here also 2 hydrogen atoms. And that is the expansion of the given bond line structure. What is given at the top is the bond line structure, and the other one is the structural formula, complete structure. You try this one, say a bond line structure like this is given to you. You try it for yourself. Too fast, you try. Okay, the complete structure. Say carbon, carbon, carbon. Here also carbon, carbon, here also carbon. That structure is given. Now you complete the structure with the hydrogen atoms. So on this hydrogen atom, 3 hydrogen atoms. Here also 3 hydrogen atoms, some methyl group. Here there is only 1 hydrogen. Here also 1 hydrogen. And here 3 hydrogen atoms. Here also 3 hydrogen atoms. Okay. And that is the complete structure of the given bond line structure. May I give you another example? Say a structure like this is given to you, and say here OH. Here comes a functional group. How to expand this? It's a triple bond between the 2 carbon, and here there is a triple bond. So carbon, triple bond, carbon. Okay. Then there is carbon, here carbon, here also carbon, here there is a OH group. That is the basic structure given to you. Now you complete the structure. Come to the first carbon, only 1 more valency, so it is H. What about the second one? Vidur, Anthony, can you say how many hydrogen atoms will be there on this carbon? Anthony, please. Yes. Sunny, you please come. Navi, can you say how many hydrogen atoms will be there? No. Vidur, you try.
No hydrogen atoms.
No hydrogen. Navin, Anthony, you are also my kids. You are also my children. So be always with me. Please don't go away. Okay. So there is no hydrogen because all the 4 valencies are satisfied here. You have to come to this. Here there will be 2 hydrogen atoms. And about this, 1 hydrogen atom. And here 3 hydrogen atoms. See, organic chemistry is very simple. It's very simple. So that is the complete structure of the given compound. So if in a structure, the carbon and hydrogen atoms are hidden and only the carbon-carbon bonds are shown by the lines that is called the bond line structure. Okay. So we can see such a figures. I call it figures, not a figure. It is a, whatever this one, say, you may say it is a square or a rectangle. That is true. In geometry, it is a square or a rectangle. But in chemistry, what it is? In chemistry, it is, yeah, there is CH2. Here, CH2. Here, CH2. Here also CH2. It is cyclobutane. Cyclobutane. The square is the bond line structure of cyclobutane. Okay. Now let us see the classification of organic compounds. Classification of organic compounds. We have already classified organic compounds into saturated and unsaturated. Saturated means carbon-carbon single bonds only. Unsaturation means carbon-carbon double bond or a triple bond. Double bond and a triple bond are known as multiple bonds. That is one way of classification. We can see some other classifications also. In your book, a number of classifications are given, but I have selected only 4 types. One is open chain structure or open chain compounds or aliphatic compounds. Open chain compounds. One, open chain compounds. They are also known as aliphatic compounds. Aliphatic compounds. They are called acyclic compounds. Acyclic compounds. Open chain compounds or aliphatic compounds or acyclic compounds. So what are the properties of the open chain compounds? As it is given open chain, there is a chain of carbon atoms in which there is no ring formation. There is no ring formation. That is a open chain structure. It may be a straight chain like say like this, straight chain, or there may be branching also. Branching, say, branching like this. That also may be there, but here there is no ring formation, as we have seen in the case of cyclopropane, cyclopentane, say butane, etc. There is no ring formation. The bonds are not closed. So that is an open chain compound. There is no ring closure. They are also known as aliphatic compounds or alicyclic compounds. So for example, CH3, CH2, 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 CH2. That is an open chain compound. All the carbon atoms are kept open. There is no ring formation. This compound CH3. This is Evelyn. Can you say here how many hydrogen atoms will be there? How many? And so carbon is equal to 4. Hydrogen is equal to 1. So how many hydrogen atoms can be there? Cannot imagine? There is only one. Here CH2, CH3, CH3. We are not doing any work. You come to this, Evelyn. How many hydrogens will be here on this carbon? Evelyn, you try. Valence carbon is equal to 4. Hydrogen is equal to 1. So carbon can form 4 covalent bonds. One covalent bond is already formed. So how many hydrogen atoms are attached? Evelyn, try. You say, maybe right or wrong, it doesn't matter. Come on. Do you hear me or not? Anthony, can you say now? Anthony, you say, how many hydrogens on this carbon, this carbon? Valency, Mohan, valency carbon is equal to 4. 4. One bond is already formed here. So carbon can form how many more bonds? Valence is equal to 4. So carbon can form 4 covalent bonds. One covalent bond is already formed between the carbon atoms. So how many valencies are left? You try. How many valencies are left? You cannot hear. Evelyn, can you hear? Can you hear?
Yes, sir.
Eh?
Yes.
A bit louder, please.
Yes, sir.
How many hydrogens?
3.
3, correct. Correct. Why do you hesitate? Why do you hesitate? It's a correct answer. CH3. Okay. You come to this. So, this carbon, how many hydrogens? Anthony, you try. You try. Otherwise, I will give the chance to Billy. You are not trying? Krishna is there? You say, Krishna, how many hydrogens will be there? Krishna. No response. You cannot understand this. Say, my dear friends, valency of carbon is equal to 4. Clear? So, carbon can form 4 covalent bonds. Okay. One covalent, say 2 covalent bonds are formed on the left and the right side. Left and the right side of this carbon. This carbon. So there is a provision for 2 more covalent bonds. So there will be 2 hydrogen atoms. Do you get me? All these are the basic principles. Here 1, 2, 3 bonds are formed already. So there is a provision for only 1 hydrogen. Here 1 bond is formed. So there will be 3 hydrogen atoms. Here also 3 hydrogen atoms. Okay. So all these are examples for open chain compounds or aliphatic compounds or alicyclic compounds. Okay. Now let us go to the second type. They are cyclic compounds. Cyclic compounds. Or they are also known as ring compounds. Cyclic compounds or ring compounds. In the cyclic compounds, there will be a ring closure. The bonds, all the bonds will be forming a ring. There is the ring closure. They close the chains will be closed. Unlike the previous one, the chain will be closed. Chain will be closed. Okay. See the structure like this. CH2, 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 CH2. Say the chain is closed. Carbon chain is closed. So it is a cyclic compound or it is a ring compound. Okay. You take, say, benzene, CH, CH, here also CH, 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 alternate single bond and a double bond. There is the closure of the chain is closed. the carbon chain is closed. Okay. So such compounds are called cyclic compounds or ring compounds. But in all these compounds, in the ring, there are only carbon atoms. In the ring, there are only carbon atoms. And such ring compounds are called homocyclic or carbocyclic. Homocyclic or carbocyclic. So in the homocyclic or carbocyclic compounds, the ring consists of carbon atoms only. In the ring, there will be only carbon atoms. There will be only carbon atoms in the ring. So they are called homocyclic compounds or carbocyclic compounds. See here, cyclopropane, benzene, all these are examples for homocyclic compounds. But there are compounds in which, in the ring, there will be an atom other than the carbon atom. An atom other than the carbon atom. A ring is there, the chain is closed, but in the closed chain, in the ring, in addition to carbon, there will be an atom other than carbon. That is called a heteroatom. Heteroatom. And such compounds are called heterocyclic compounds. Heterocyclic compounds. So in the heterocyclic compounds, in the ring, there will be a heteroatom, like say nitrogen, oxygen, sulfur, etc., in the ring. In addition to carbon, in the ring, there will be nitrogen, oxygen, sulfur, etc. For example, you take a compound furan. Say the structure of a furan, it is like this. So this is the structure of a furan. It is a cyclic compound, a ring compound. In the ring, in addition to carbon, there is oxygen. See here, at these corners, here there is carbon, here there is carbon, here carbon, here carbon. So there is a ring of 4 carbons along with the oxygen atom. So in the ring, 4 carbon atoms and 1 oxygen atom. So there is a heteroatom, an atom other than carbon. It is a heterocyclic compound. For example, furan. You take thiophene, a compound, thiophene, say compound like this. Here also there is a ring, and this is called a thiophene. Thio means sulfur. Thio is sulfur. So in the ring, there is a sulfur atom. In the ring, there are 4 carbon atoms. Here 4 carbon atoms are there. But in addition to the 4 carbon atoms, there is a heteroatom sulfur in the ring. Similarly, you take pyran. Say pyran is this one. A structure like this. Here there is oxygen, and this is pyran. Or pyran. Heterocyclic compound. In the ring, there is oxygen atom. Or you take pyridine, another compound called pyridine. In the ring, in addition to carbon, there will be nitrogen also. And this compound is pyridine. In the ring, there is a nitrogen atom. So the compounds containing an atom other than carbon in the ring. An atom other than carbon in the ring is called a heterocyclic compound. But if there are only carbon atoms in the ring, it is homocyclic or a carbocyclic compounds. And I have taken one more, that is aromatic compound. aromatic compounds. Aromatic compounds. These are benzene and benzene-like compounds. Benzene and benzene-like compounds. Benzenoid, or benzene-like. Benzene and benzene-like compounds. These are called aromatic compounds. We need not go deep into the definition of aromatic. Simply understand that these are benzene and benzene-like compounds. Compounds related to benzene. They are aromatic compounds. So these are the various types of compounds. So that's about the classification of the organic compounds. This much is enough for us for the time being. More details we can see later. Now you come to another point, functional group. You have studied this in the 10th standard. Functional group. And what's a functional group? What is a functional group? A functional group is one, it is the heteroatom or a group of atoms. It is the heteroatom or group of atoms. Group of heteroatoms, group of atoms which confers, which gives, which confers the peculiar properties, specific properties to a compound or a group of compounds. A compound or a group of compounds. That is called the functional group. A heteroatom or a group of atoms which confers specific properties to compounds. You take a group of compounds. So these are called the functional groups. Say there may be the halogen atoms, say fluorine, chlorine, bromine, iodine, etc. as the functional group. That is a heteroatom. You take so this is for a halo compounds. Halo compounds. The functional group is the halogen atom. You take alcohols. A group of compounds called alcohols. Alcohols or phenols. Phenols. Alcohols you have had in the 10th standard. Phenols. We are going to see phenols. Phenols. So in all these, there will be the OH group as the functional group. Hydroxy group or OH group. There will be carboxylic acids. Carboxylic acids. We remember the group is a C double bond OH group. That is the carboxyl group. COOH group, carboxyl group. All the carboxylic acids have the same properties, chemical properties. And it is due to the presence of this common group in the carboxylic acids. Similarly, you take aldehydes, a group of compounds called aldehydes. In the aldehydes, there will be the functional group CHO double bond O. Or you can write it as CHO. This group is called aldehyde group. CHO group or aldehyde group. You take ketones, another class of compounds, ketones. In ketones, there will be C double bond O group. And that group is called the ketonic group. All the ketones will be containing C double bond O group. And so all the ketones will be having similar chemical properties. So there will be a heteroatom, see here, heteroatom or a group of atoms which gives special common properties, specific common properties to a group of compounds, a class of compounds. They are called, such groups are called functional groups. These are the reactive groups in a given compound. Acid or alcohol or aldehyde or ketone, whichever be the compound. there will be a reactive group. And that reactive group, the group that functions, the group that functions is called the functional group. The group that functions is called the functional group. Okay. All this, the repetitions of the 10 standard. That is why I am going too fast. Let us see one more point today, and after that we can stop. That is also you have studied in the 10th standard homologous series. You have studied this in the 10th standard homologous series. Homologous series is a class of compounds, that is a series of compounds with the same properties, which are the same properties. They are composed of the same elements. There will be a general formula. They can be represented by a general formula. There will be a general formula for all the members in the homologous series. Second, there will be a common functional group or a general functional group. There is a common functional group. Same functional group. There will be same functional group. Since there are same functional groups, they have similar chemical properties. Similar chemical properties. Because chemical properties are related to the functional groups. The functional groups are the same. The functional groups are the same, and therefore chemical properties, same chemical properties. Okay. So they have the same functional group and some similar chemical properties. There will be a gradation in the physical properties. Okay. Then one more point you have to remember. You take two successive members. Two successive members. They differ in a CH2 group. In the molecular formula of two successive members, there will be a difference of a CH2 group. You consider the mass of a CH2 group, carbon 12 hydrogen 2, so 14 U. The difference in molecular mass will be 14 U between two successive members. And such a group of, such a series of compounds is called a homologous series. So homologous series means a series of compounds with the general formula, same functional group, similar chemical properties, and the successive members differ in a CH2 group, or the mass difference will be 14U. 14U is corresponding to CH2. That is the mass of a CH2. And such a series of compounds are called a homologous series. For example, you take alkanes. Alkanes. Alkanes are hydrocarbons. Hydrocarbons. Then you take alkenes. Alkenes. Then you take alkynes. More details we can see. All these are various homologous series. Alkanes, they can form a homologous series. Alkenes, another homologous series. Alkynes, yet another homologous series. More details about alkanes, alkenes, and alkynes. You can see, you have heard about this in the 10th standard. Alkenes, alkanes, alkynes, we have seen already. So homologous series means a series of a group of compounds with a general formula, same functional group, similar chemical properties, and the successive members differ in a CH2 group or a mass difference of 14U. Examples, alkanes, alkenes, and alkynes. These are three different types of, three different groups of homologous series. Okay. So this is enough for today. More details. All these things, the majority of these portions you have already studied in the 10th standard. Do you remember this or not? Yeah? Do you remember? I
Yes,
have.
sir. Yes, sir.
So all this we can easily finish. The next topics onwards, slightly different. Slightly different. Tomorrow onwards, next class onwards, slightly different. But that is not much different. There is nothing to worry about organic. It's very simple. Don't worry. It's very simple. But the thing is, there's the basic principles you should know. You should know. Okay. So let us meet again in the next class. Thank you.